Okay, in this video we're going to start to look at piecewise functions that we're going to try to make both differentiable and continuous. Remember, if we make something differentiable and we've solved all the answers, we don't have to go any farther, but sometimes it's not enough information. I'm starting with this piecewise function of x to the third. Okay, so we're given the original function. In order to check to see if it's differentiable, we need to take its derivative. We treat any constants as constants. And we're going to take the derivative of this function. Derivative of x to the third, yes it is an x, is 3x squared, for x is less than 1. And for the next one, it's going to be, I'm going to pick the 2 out in front, so it's going to be 2a, parentheses, x minus 2, times the derivative of the inside, which is there is nothing, plus the derivative of b. Derivative of b is 0, so I'm not going to add anything on. For x is greater than or equal to 1. I'm now going to prove make it differentiable by making the limit of the derivative from the left equal the limit of the derivative from the right equal the derivative at our value, which is 1. Let me write this out. So there's our statement. We're going to fill it in. Just remember, we're always going to put the 1 into the top and into the bottom. And write them on out. So this is going to be 3 times 1 squared, which is 3, equals 2a times 2 minus 1. What is 2a times 1 minus 2, which is going to be negative 1. 1 minus 2 is not negative 1, it's negative 3. Who said negative 1? Nice try. Equals the derivative at negative 1. I'm going to use the bottom part because that's when it's equal. So that is also going to be, who said 3? Oh man, you got me. It's going to be 2a, let's write this out, 2a times 1 minus 2, which is negative 1. I was right the first time. Equals 2a times negative 1. We can dump this piece because it's extraneous. And now we can go ahead and solve this for a. I believe we can solve it for a. Let's go ahead and solve it. So we've got 3 equals negative 2a, and therefore we know that a is equal to 3 over negative 2 or negative 3 over 2. That solves our a, but that doesn't get us our b yet. We still need our b for our original function. So we're going to go ahead and we're going to fill the information into the original function to make it continuous. Like I said, sometimes you don't have to do it, but because we have 2 variables, we're going to have to fill it on in. So we're going to fill in our 1. 1 to the third power is 1. Now we're going to fill this on in here. This becomes a times 1 minus 2, which is negative 1 squared, which is 1 plus b, is equal to a times 1 plus b. Extraneous part again, we'll delete that. We've got 1 equals a plus b, and we could now use the information we have here to solve for b. We'll go ahead and fill in the negative 3 over 2 for a. So we get 1 equals negative 3 over 2 plus b. I've got to get b by itself, so I'm going to add 3 over 2 to both sides. And continue this over here so I don't run out of room. They cancel. That's 2 over 2 plus 3 over 2 is 5 over 2 equals b. So we've now solved our equation for a and for b. We can substitute it into the original equation, which is the following. And here's the solution for our function right here. How are we going to verify that? We're going to graph it in the calculator and make sure we get a continuous and differentiable function. So it'll be smooth and not have a cusp.